Hello, beautiful students. It's good to see Salt here today, and Ruby, and Anna, and Floria, and Lynn. Okay, I've been talking with Salt, and he said he had some problems with some questions. I don't know about the rest of you guys. Uh, do you have anybody has some other problems with the questions? Um, If not, then I will only look at the questions that Salt said he had problems with, and maybe that will reinforce your understanding of some stuff. So maybe this class is not going to be very useful for all of you. If everything is fine with some of you, then the class is not going to be very useful. Okay? Uh, okay, let me share my screen now. Mm-hmm. Sod was saying that he had problems. He had a problem with question 3, right? Right, Sod? Sod.
Not three.
You are not talking, Sod.
Really.
Huh? See, I cannot hear him. Okay, it's not very clear here, but it's okay. A girl is dragging a suitcase of mass. Who is that? 15, 16, 17. Okay. Let me look at 15, 16, 17 for you, Sod. Let me look at 15, 16, 17 for you, Sod. That is question 15. Okay, we are told that coplanar forces. Coplanar, this means forces on the same plane. They lie on the same plane. They lie on the same plane. Meaning that if this screen, like my computer screen, is a plane, then all the forces lie on this plane. No force is perpendicular or at an angle to this screen, okay? So all the forces are on this plane. When they say coplanar forces, they are telling you that you can just use maybe two perpendicular directions, the y and the x directions. No z direction, no z. So coplanar forces of magnitude this, that, and that act at a point in the direction shown in this diagram. You are told that tan theta is this. You will see questions like this in exams. So many questions that give you values like this. Tan alpha is this. You'll be given sine alpha is this, cos alpha is this, and so on, right? So if you are told tan alpha is 5/12, you need to find cos alpha first. So if we have, for instance, if you have a triangle like this and this angle is alpha, tan alpha is 5/12. So it means this side is 5 and this side is 12. So you have to calculate this side, square root of 12 squared plus 5 squared. What is that, sort? So it's square root of 144 plus 25, which is square root of 144 plus 25. That is square root of 169. What is it? It's 13, right? Square root of 169 is 13, isn't it? Oh, 169 here. So this side is 13 units. So this means that cos alpha is 12/13 and sine alpha is 5/13. So you are asked to find the magnitude and direction of the resultant force. All you need to do is to find the magnitude and direction of the resultant force. You first find the force as a vector. The x direction, this one has no component in the x direction. The x component of this force is 0. The x component of this force is 31. And the x component of this force is 26 cos alpha. 26 cos alpha. And then you look for the sum of the y components. The y component of this force, of the 58 Newton force, is just 58. The y component of the 31 Newton force is 0. The y component of the 26 Newton force is negative. It's in the negative y direction. So it's negative 26 sine alpha. Right? Right, Sword? Sword, do you confirm this?
Yes.
Do you understand how we get this?
Yes.
You break all forces into x and y components, and then you sum all the x components and sum all the y components. The component of any force in the direction and the angle is alpha, it will be that force cos alpha. And then if the component that is perpendicular, the component that is perpendicular to alpha is that force times sine of alpha, right? Once you sum this, it's done. So we are going to get 0 plus 31, just 31, plus 26 cos alpha is 26 times 12 over 13. And this is 58 minus 26 times 5 over 13. What is that? That gives us 31 plus 24, correct? And this gives us 58 minus 10, correct? So we get 7 newtons that way and 42 newtons in the y direction. So the magnitude. So from here, you can see that our force, so the resultant force will look like this. Let me do it better. 7 newtons in the x direction. So this is our resultant force, correct? You need to look for the magnitude. This point is 7 newtons in the x direction and 42 newtons in the y direction. You need to look for the magnitude and this angle, theta. So magnitude of F, just call that F, is equal to square root of 7 squared plus 42 squared. Square root of 7 squared plus 42 squared. That gives us 42.6 newtons. So it's 42.6 newtons. And direction, you just find the angle theta. Theta will be tan inverse of 7. Is it tan inverse of 42 over 7? Or 7 over 42? Tan inverse of 42 over 7. I need to make sure my calculator is in degrees. I want to give the angle in degrees, not radians. Tan inverse of 42 over 7. That gives me 80.5 degrees. So 80.5 degrees. So this is even slanted up. It's very close to 90 degrees. So when you end here, most of you guys, after you solve these problems, you never write a conclusion. It is either you have a diagram like this to show which angle is theta, Or after you solve, you give a conclusion. You have to say, therefore, the resultant is 42.6 newtons at 80.5 degrees above the x-axis, above the positive x-axis. Another person could give this other angle. Another student maybe will give this other angle. Let's call that beta. Beta is 90 minus 80.5. So that is 9.5 degrees. So another person could say the resultant is 42.6 newtons at an angle of 9.5 degrees to the right of the y-axis, or at a bearing of 9.5 degrees. This is also okay. Both you give that, you state that, or you state this, it's all correct. Okay? Which other question did Saul talk about? I think you should be able to solve the rest of the problems now, Saul. You've not been attending classes. Saying your internet is not good. It's not your fault, but you should try. 16 says a particle P of mass 1.05 kilograms is attached to one end of each of two light inextensible strings of length 2.6 meters and 1.25 meters. The other ends of the strings are attached to a fixed point A and B, to fixed points A and B, which are at the same horizontal level. P hangs in equilibrium at a point 1 meter below level of A and B. Find the tensions in the string. This is a very interesting problem. Okay, it's a past question problem, so I can understand. Usually, past question problems have this kind of problems on finding tension in the string. So let me redraw this. Okay. So you have to ask yourself what forces are acting on this object. You have the weight. You have the weight. What is the weight of that object? 10.5. 10.5 newtons. And then you have a tension here, T1. Because the length of the strings are not the same, so the tension will not be the same. You have a tension here, T2. And they are both in equilibrium. So all you need to do is find this angle here, theta, and this angle here, alpha. This angle is the same as this. And this angle here is the same as that one. So, how to find those angles? You have been given the lengths of the strings, 2.6 meters and 1.25 meters. So this is 2.6 and this is 1.25. So we are told that P hangs 1 meter below level of A and B. So this length here, this length is 1 meter. If this is 1.25 and this is 1 meter, then we can find this angle, right? So we have sine theta is 1 over 1.25. And we have cos, should we have cos theta? Cos theta will be what? Sine theta is 1 over 1.25, so cos theta will be 1 minus 1 all over 1.25 squared. You can calculate that. And then we have, this is also 1. So sine alpha is 1 all over 2.6. Cos alpha will be 1 minus 1 all over 2.6 squared. And then from here now, you resolve these forces. The T, the component of T1 this way will be T1 cos theta. And the component upward will be T1 sine theta. And the component of T2 this way will be T2 cos alpha. And the component upward will be T2 sine alpha. So what you need to do now is resolve the forces vertically and horizontally. If you resolve horizontally, you will get T1 cos theta should be T2 cos alpha. This is equation 1. You resolve vertically, you will get T1 sum of forces upward should be sum of forces downward. So T1 sine theta plus T2 sine alpha should be equal to 10.5 newtons. That is equation 2. You solve equation 1 and equation 2 to get T1 and T2. You already have sine theta, sine alpha, cos theta, cos alpha. So just substitute them here and then solve for T1 and T2. Okay, solved. Is that solved?
Okay.
For someone like Floria who studied Lami's theorem, this problem will be very easy to solve using Lami's theorem. But I don't want to go into that here since all of you did not study Lami's theorem. But still, you will never be given problems that only require Lami's theorem. So you don't need to learn it. I think you should be able to solve the next problem now, so you should try. I would like to look at one problem that you guys did not solve because I skipped these problems, question 8 to question 14. And you are not going to solve them. Okay. Is that it? What happened? I'm sorry, this thing is very slow and we may finally not have time to complete even one question here. So we are told here that a girl drags a stone of block of mass 18 kilograms up a slope at an angle of 13 degrees. This is also an interesting problem you may have in an exam. So there is a slope of 13 degrees here, and a girl drags a stone of mass 18 kilograms. So the weight will be 180 newtons. And the acceleration that the girl drags with, the acceleration is even. Acceleration is 0.7 meters per second squared. We're asked to find the mass of the heaviest block that the girl can drag. If this force that she drags with is the maximum force she can apply. If this is the maximum force she can apply. So we need to find the force here. In this case, we need to find the force. So there is also a normal reaction here, call it R, and the girl is dragging with a force F, which we need to find, right? So now we can resolve our weight into perpendicular component. This will be 180 cos 13. And here, parallel will be 180 sine 13. Somebody asking me a question or something? Oh, not you guys. Teaching online and you're getting messages. Okay. So now we resolve parallel to the plane. All we need to know, we are not asked to calculate R, so we don't need to resolve perpendicular to the plane. It's not necessary. We only resolve parallel to the plane. So we are applying Newton's second law parallel to the plane. So we get this force minus this force should be the mass times the acceleration. So F minus 180 sine 13 should be the mass of the object, which is 18, times the acceleration, which is 0.7. So that gives us F as 18 times 0.7 plus 180 sine 13. What does that give us? (18 times 0.7 plus 180 180 180 sine 13. That gives us 53.1.09. 53.09 newtons. And if this girl can apply this force, this is the maximum force that the girl can apply. So we should find the maximum mass that she can drag up the slope. To drag the maximum mass up the slope, there should be no acceleration, right? So for the second part of the problem now, we still have that slope, and we have an object of mass m. So this will be mg. So you can see that there will be a component this way, which is mg sine 13. And she still has to drag with that force, 53.09 newtons. So we are asked to find m now. Remember, this time around, there should be no acceleration, because if she is dragging with, to get the maximum mass here, she should drag at constant speed up. There should be no acceleration upward. So you have 53.03 should be equal to mg sine 13. That will give you m as 53.03 divided by 10 sine 13. Okay? That will give you the maximum mass she can drag up the slope. I just solved that problem because I did not ask you guys to solve them before. For today, your homework today will involve looking at cross-topic questions. Cross-topic review. Question 1 to 8. Okay? So it should be these questions. Cross-topic review. The first page, question 1 to 8, page 80. Okay? Submit on Edmodo. Thank you very much and see you guys.